Hello students and welcome to our class today. Today's class is going to focus on a new area or a new solid which we normally call a pyramid. We are going to focus on a solid we normally call a pyramid. A pyramid can be of 3 or even 4 categories, but in our case we are going to focus on 2 types of pyramids. A pyramid whose base is square and a pyramid whose base is rectangular is going to form our focus. So it is actually a figure that has got this shape. It has a common vertex like that. So actually that is what we normally refer as a pyramid. So a pyramid can be a pyramid whose base is actually a square, meaning that all sides of the base are equal, or it can be a pyramid whose base is actually rectangular, meaning that the two opposite sides are the same, and actually the two faces of the slant edges or the slant faces are also going to be similar. So let us talk about the square based pyramid. The square based pyramid, it simply means that the base of that particular pyramid is actually a square, meaning that all these four sides are the same. So if we have the vertex there, and we draw it like that, so you can have A, B, C, D, and then this one we can call V. You can be able to realize that if this is a square, it simply means that this face that is going to be maybe this one that is on this side, this face that I've shaded here, is going to be the same as this one that is here, is going to be the same as this one that is on this side, is the same as the other one that is going to be on this particular side, like that. All the faces are going to be the same. Also, in pyramid, our focus will be on 2 things. Number one is how do we get the volume of a pyramid? Number two, how do we get the surface area of a pyramid? So let us start with the first focus, which is how do we get the volume of a pyramid? Volume of a pyramid. The volume of a pyramid is normally given by the formula a third times the base area times perpendicular height. So remember here, when we talk about the base area, it depends with the nature of the base. If it is a square, we know how do we get the area of that particular square base, which is length times length. If it is a rectangular, we know how do we get the area of a rectangle, which is length times width, and so on and so forth. So if, for example, we have our pyramid like this, we have a pyramid like that, and we have been given this length as maybe 6 by 6, meaning it's a square, and then you have been given the height. The perpendicular height is the height from the vertex to the center of the base, like that. Now you are told, can you calculate the the volume, given that this height is maybe 8 centimeters? So what are we going to do? The volume will be given by a third times the area of the base, which is 6 by 6, times the perpendicular height, 6 by 6, sorry, times the perpendicular height, which is actually 8. So you'll find that this one is going to be a third times 36 times 8. The D goes to 36 12 times. So we are going to have, it is going to be equal to 12 by 8. 12 by 8, which is giving us 96. That is 96 centimeters cubed. Always volume, make sure that the units are raised to power 3 or cubed. What about if it was a rectangular based? If we are given a pyramid that is having a shape like that, if it is having the shape, maybe you are told that this side is 10 and this side is 7, and then the height here you have been told is 12 centimeters. So you'll find that the volume is going to be a that times the area of the base, which is a rectangular, 10 times 7 times the height, which is 12. So how are we going to go through this? This is 10 times 7 times 4. That is 70 times 4, which gives us 280 centimeters cubed. 280 centimeters cubed. And that is how we get the volume of a pyramid. But more often, maybe you can be given a, a, a pyramid, maybe the perpendicular height is not given. You can be given a pyramid that is having this dimension. You have been given the dimensions like this, that maybe this is 10 by 8, and then you have been given maybe this slant edge from this corner to the vertex. Maybe you have been told it is 12. Now you have been asked, can you calculate the volume? Remember, you cannot be able to calculate this volume before you get this perpendicular height up to the center from the vertex like that. So you need to come up with a way of getting this. So you need to note this. If we join this end to this end, if we join it like this, if we join it like this and we have the center there, we are actually going to have what? Or alternatively, you can be able to know that if we have the base, remember all these bases are going to have an angle of 90 degrees. So if we have an angle of 90 degrees at a particular point, this point is 90 degrees, whereby this is 10 and this side is 8, are we able to get this diagonal here, which is actually the same as this diagonal here? So if this is 10 and this is 8, we have it here. Remember, even though the shape looks like this particular angle is 90 degrees, because we know a square and a rectangle, they normally have all the angles equal to 90 degrees. So you can be able to get that, which is the same as our hypotenuse, which is going to be h is equals to the square root of 8 squared plus 10 squared, which is the same as 64 plus 100, the square root. So we can come here and you say the square root of 164, which is the same as 12.8, which is actually the diagonal. Let us call it the diagonal. From this end to this end is 12.8. 12.8. If this diagonal is 12.8 from this end to this end, then up to the center is going to be 6.4. 6.4. So we can have a right angled triangle that is behaving like this now. This is H. From here to the center here, which is the same as from this end to the center, it is 6.4. And then this rand height, we have been told it is 12. And now we can be able to get the perpendicular height, which is actually the height from here to here. Hope you can be able to see that. From here to here, it is 12.8. Up to the center here, it is 6.4. So it is from this end to this end, which is the same as from here to here. And then this 12, it is the same as this round height that we have been given here. And then we have the perpendicular height which we are interested. So we are going to have that particular right angled triangle where we have 6.4 as the base. The slant is 12, like that, and then we can be able to get the 12. So the height, sorry. So the height will be the same as 12 squared minus 6.4 squared, like that. We take the square root, which is the same as 144 minus 6.4 squared, which is the same as 40.96 minus, which is the same as, we take the square root, which is the same as the square root of 103.04. The square root of 103.04, which is the same as 10.15. That is the perpendicular height. Now the volume will be equal to a third times the base area, which is 10 times 8 is 8, times the height, which is 10.15. So this one you multiply by 8, then we divide by 3, which is the same as, now the volume will be equal to 270.69 centimeters cubed. And you are done. So you must be very careful on what you have been given and how you can be able to get a figure that you need, though it is not given. Thank you very much.